So good morning. Sorry, there was a network issue. We have changed the network. We will see. Okay. So good morning. Good morning to everyone. So I was talking about yesterday's one only. So that is Gabriel Thalimide method for the biosynthesis or synthesis of amines. That is Gabriel Thalimide method. Now when I am talking about Gabriel Thalimide, that is Thalimide. This is the molecule Thalimide. Now when I am talking about this one, what is the first step? First step is treatment with the alcoholic potassium hydroxide. First step is treatment with the alcoholic potassium hydroxide. Then we are going to get an alkyl derivative. Right? Then we are going to get an alkyl derivative as the intermediate. So that's where we have the R, means potassium, which is in attachment with this one, which later can be converted into an alkyl derivative when I will treat with the alkyl halide. When I will treat with the alkyl halide, then it can be converted into CO. Right? So that's where I am going to have the N-alkyl thalimide. This is nothing but N-alkyl thalimide. Now later when I treat with sodium hydroxide, then it will get converted into respective amines. It will get converted into respective amine. Along with that I am going to get the disodium phthalate as the side product. Even we can go with sodium hydroxide or we can go with the hydrazine NH2 NH2. Any one of these two reagents can be used to have the product. All of you have understood? Now at the same time we have discussed about physical properties. We have discussed about the physical properties of the amines, and then if I go with amines having similar molecular weight, in that case I can tell that primary amines will have the higher boiling point compared to secondary, and the last one is tertiary. So what is the reason? Reason is due to the intermolecular hydrogen bond. Reason is due to the intermolecular hydrogen bond, where primary amines are having more options to form the intermolecular hydrogen bond. So this is related to physical properties. Now when it comes to chemical reaction, that's what we were discussing with respect to the chemical reactions. So now when I am talking about chemical reactions, yesterday we have came to a conclusion that always ammonia will be having least Lewis base character. Always ammonia. Okay, I have not told Hoffman bromide synthesis. Yes, okay, fine. So when it comes to synthesis, even we have discussed a very important one, that is Hoffman bromide synthesis. Once again, where amide will be used, right? So we have two methods for the conversion of amides to amine. One is Hoffman bromide method and another one is amine when under reduction condition or reducing condition. That is lithium aluminium hydride. But when I am using lithium aluminium hydride, I am getting increment in the number of carbon. But when I am going for Hoffman bromide synthesis, now here there is no increment in the number of carbon. That is the difference. Try to remember this one. Okay? So that's what we have discussed. Now when it comes to chemical properties, I was telling that ammonia will be having least Lewis base character. Why? What is the reason? That is because why ammonia will be having least Lewis base character? Any one of you? As ammonia, yes, it is Lewis base, no doubt. But when I compare with the amines, ammonia will be having least Lewis base character due to the presence of 3 hydrogen. There is no alkyl group. Then comes the primary amine, then comes the secondary, then comes the tertiary. So that's what we have discussed, right? So when I am talking about organic solvent, so under that condition, this can be the arrangement. This can be the arrangement, that is due to positive inductive effect. That is due to positive inductive effect, because when I am talking about tertiary amine, it will be having 3 alkyl groups. It will be having 3 alkyl groups. So therefore, it can easily donate the electron. It can easily donate the electron to another electrophile. It can be H plus or anyone. That is because of the positive inductive effect of the alkyl group shown by the alkyl group, which will be pushing the electron towards the nitrogen. So therefore, this lone pair of electron can be easily donated. So that's where tertiary amines will be dominating when it comes to Lewis base character. If I focus on inductive effect, if I consider only the inductive effect is the condition, right? Now, when it comes to other factors, please remember that's what I was telling yesterday. Now, when I am talking about Lewis base character, one factor is inductive effect, which is going to decide Lewis base character. Next one is solvation energy. Next one is solvation energy. Next one is steric factor. These are the 3 factors we have to consider. One is inductive effect. Which type of inductive effect? Positive inductive effect, no doubt, due to the alkyl group. Next one is solvation energy. And next one is steric hindrance. Now, inductive effect, already we have discussed. What will be the scenario when I am talking about inductive effect? This will be the arrangement. Now, if I take solvation energy and steric factor, now we have a condition when it comes to the primary amine, hydrogen, hydrogen, then R. All of you should agree that compared to hydrogen, alkyl group will be larger, right? It will be large molecule compared to hydrogen, which is small. For example, if I go with ethyl group, then C2H5N, right? So that's where I have the ethanamine, where one ethyl group is there. Naturally, ethyl group is a large molecule compared to the hydrogen, right? So this is with respect to primary. Now when it comes to secondary, I will replace another hydrogen by another ethyl group. Now it will become diethanamine. So it is a secondary. Now nitrogen is surrounded by 2 ethyl groups. Here only one ethyl group, but there 2 ethyl groups are there, right? Now I will come to tertiary, where another hydrogen I will replace. I am going to replace the another hydrogen. Now what is happening? Nitrogen is surrounded by large molecules. Nitrogen is surrounded by large molecule, which is that one ethyl group. Now we will imagine we have a electrophile. We have a electrophile. For this electrophile to enter into this location, it requires some space. But when it comes to tertiary amines, that space is less. Please remember, here I have written on the board, but when it comes to in reality, it will be 3D. It is like a 3D view. Fine? So that's where we have the tertiary amine, where lone pair of electron to attack this electrophile, there is a hindrance due to the large molecules. Now same logic is applicable here and same logic is applicable here. Since very less amount of molecular groups are there in primary, now it can be easily attacked by the electrophiles. Right? So it's very simple. Raghavendra sir is standing here. Now Raghavendra sir is discussing with one student. Now for you people, you can see me. Raghavendra sir, you can see me easily and you can approach me. Now Raghavendra sir is surrounded by two students. Now only from one side you can see the Raghavendra sir, because other two side I have my students. Now Raghavendra sir is surrounded by three students. Now what will happen? And we will imagine all of them well built students. Okay now? So you can imagine, now you can't see the Raghavendra sir. Same logic is applicable here. You can imagine nitrogen as a Raghavendra sir, and that's where we have the students. Right? So as the bulkiness of the molecule will increase around the central element, naturally it will be called as a steric hindrance. It causes the steric hindrance. So as there is an increase in the steric hindrance, Lewis base character is going to decrease. All of you are getting it? All of you are understanding? That's what I mean to tell. That is one thing. So we came to know about the inductive effect. We came to know about the steric factor. They are contrasting each other. Observe it carefully. They are contrasting each other. In one case, yes, it will tell that this should be the arrangement. According to inductive effect, this should be the arrangement. But if I go with steric hindrance, I can see very high steric hindrance with respect to tertiary amines. Right? So in that case, I can arrange, still ammonia will be least, no doubt, because there is no alkyl group. Now comes the primary, then comes the tertiary, then comes the secondary. That is based on the steric factor. Or tertiary amine, even it can shift it to primary amine side also, depending on the alkyl group. So that can be the arrangement. All of you will agree? This is one thing. Next one is, I have amine. When I will put it into water, all of us will know that water is neutral because it is having equal amount of H plus OH minus. It can give equal amount of H plus and OH minus. So that's where Lewis base character are NH3 plus OH minus. So that's where they will form the basic solution due to the formation of OH minus. What is happening? We have the amine. In the presence of water, they will attack the H plus, or they will take up the H plus, and OH minus will be as it is. So therefore, whenever I will put amines into water, I am going to have the basic pH, alkaline pH or alkaline condition due to the OH minus. Now if you observe, we have positive ion, negative ion, aqueous and aqueous, right? So that's where I have the condition. Both are getting converted into ions. Now I will increase from primary, I will straight away go to tertiary amines. Now I am going to have R, H positive and OH minus. Right? Now there is a problem because alkyl groups are more. Solubility will be a problem. All of you will agree? Since there is an increase in the hydrocarbon part, alkyl group is getting increased. Solubility is going to slightly decrease. Compared to here. Solubility is going to decrease. So what I mean to tell here is solubility, that is nothing but how a molecule is going to interact with the solvent. That is called as solubility. If I consider water, in that case I can tell that tertiary amines will have less solvation energy compared to primary amines, or I can tell that tertiary amines will be bit less soluble compared to the primary or secondary amines. right? Since they are more soluble, they can easily undergo the reaction. Since it is less soluble, less stability, they will come back to the original condition. That's where the equilibrium will be shifted. So that's what you people have discussed in your thermochemical equilibrium topic in first year, right? So that's where you should understand. Now based on the solvation energy, once again I can go with the same scenario. Once again I can go with the same scenario. If I consider solvent as water, if I consider solvent as water, then it will be the almost same scenario where secondary amines they are going to dominate. But whatever it might be, ammonia will be least Lewis base character due to the absence of the alkyl group. But as a single ammonia, yes, it is a Lewis base. All of you are understanding? Any doubts? Until this, any doubts are there? So that's where we have the three factors. One is inductive effect, that is positive inductive effect, which is due to the alkyl group attached to the nitrogen with respect to amines. So this is not there with respect to ammonia. So therefore it will be having least Lewis base character when it compares to the amines. Then comes the solvation energy. Solvation energy means whatever products are getting formed, how easily they are getting soluble in the respective solvent. If that is the case, if I consider as the water as the solvent, then I can tell that primary amines are more soluble compared to the tertiary. So as the solubility increases, more solvation energy will be released. So process can happen easily. Wherever energy gets released, process can happen easily. So that's where this arrangement cannot be acceptable. Now we can go with this. There is a slight interchanging in the position of tertiary and secondary amines. Then comes the steric factor. Naturally, when it comes to the steric factor, it is related to how much space is available. How much space is available for a new molecule, that is electrophile, to enter into and attach to the nitrogen. How much space is there around the nitrogen? So according to that, naturally, since tertiary amines are surrounded by three bulkier molecules, they will provide less place or space for the attacking reagent, that is electrophile. So therefore, even if I go with steric factor, this will be the condition. This will be the condition. So what I mean to tell here is, in general we can tell that ammonia, they are least Lewis base compared to amines, and among the amines, primary amines will be less Lewis base compared to secondary and tertiary. But when it comes to secondary and tertiary, their position will be decided by a type of alkyl group and in which solvent we are making the reactions to happen. Fine? All of you have understood? So that's where we have the Lewis base character. For competitive exam, it may be helpful for you, all this concept. Whether all of you have understood? Any doubts? Board exam, I don't think they have asked on this. But for competitive exams, yes, it will be helpful. But that doesn't mean that for board exam this year also they will not ask. 1 mark question they can ask on this aspect. Fine? Right? As I have discussed, we have amines. Already I have written this reaction plus water getting converted into R NH3 plus OH minus. So this is the reaction, right? So if I want to write the rate constant, for this reaction, that is nothing but equilibrium constant, then it will be concentration of the product concentration divided by product of reactant concentration multiplied by water, right? Now, if you go back to the first year class, chemical equilibrium, we had written this type of equation. Rate constant, that's where this will be the relation. Now, all of us will know water, we will consider it as unity 1 because there should not be change in the concentration of the water. Because from a bucket of water, if I remove 1 spoon, whether anything will happen to the volume of water in the bucket? No, it will be neglectable. So therefore, I can write it as K is equal to R NH3 plus OH minus divided by R NH2. So that's where I have the K value. Now since we are talking about Lewis base character, I can write it as Kb. I can write it as Kb. That will be the arrangement. Right? Now as that we have the pH, relation between H plus concentration and the pH. Same way for Kb also. We have pKb, which is equal to minus log of Kb. pKb is equal to minus log of Kb. Everything you people have studied in your chemical equilibrium topic of first year, no doubt. So pKb is equal to minus log of Kb, same as that of pH is equal to minus log of H plus concentration, same thing. Right? Since we are dealing with Lewis base, that's why I have written it as Kb. If I am talking about acid, it will become Ka. Fine? But meaning is same. So that's why we have pKb is equal to minus log of Kb. If I rewrite this equation, I can tell that pKb is equal to log of 1 by Kb. Right? Log of 1 by Kb, because minus sign is there. Now there is no minus sign. Right? So that's where we have the equation. I can observe pKb and Kb, they are inversely related to each other. pKb and Kb, they are inversely related to each other. That's what I can conclude by these two equations. As there is an increase in the Kb value, pKb value has to decrease. As there is a decrease in the Kb value, pKb value should get increase. Right? So that is the relation between pKb and Kb, just like pH and H plus concentration. As there is an increase in the H plus concentration, pH value is going to decrease. Same logic is applicable. As there is an increase in the Kb, pKb value should get decrease. All of you have understood? Fine. Any doubts? If that is the case, you should tell me. You should tell me. When I take the ammonia, when I consider the ammonia, pKb value of ammonia, whether it should be less than amines or it should be more than amines. If you have understood whatever I have taught now, you should tell me that what will be the relation between Kb, what will be the value of pKb when it comes to ammonia, and if you compare with the amines. What will be the value of pKb for ammonia? Whether it should be less or it should be more. Kb, already I have explained. You know the equation. What is that Kb? pKb and Kb relation I told. Now the question is very simple. What will be the pKb value of ammonia compared to amines? Whether it should be less or it should be more. Okay, Kritik, you are absolutely right. It should be more. It cannot be less. It should be more because Kb value will be less. Please remember, Kb is equal to R NH3 plus. Okay? And another product will be OH minus. So divided by R NH2. I am considering R, primary amines. R can be replaced by hydrogen if I take ammonia. Now Kb value is getting increased means Lewis base character is increased. Kb value is getting increased means Lewis base character is increased because more amount of this product has been formed, right? So more amount of H plus has been taken. Then only we can have the more amount of product. As the value of this one increases, Kb value will also increase. Yes or no? So in that way I can tell that since Kb value is getting increased, there should be decrease in the pKb value. There should be decrease in the pKb value. Therefore I can tell that Lewis base character is directly proportional to the Kb and indirectly proportional to the pKb. Lewis base character is directly proportional to Kb value. As there is increase in the Kb, Lewis base character is more potent. That's what I can see. Since Kb and pKb they are inversely related, I can tell that Lewis base character is directly proportional to Kb and inversely proportional to pKb. Still, if you have any doubt, let me know. I am ready to explain it. All of you have understood?
Yes, between ammonia and amine.
Okay, ammonia and amine I asked. And it's well known that ammonia is having less Lewis base character. That means Kb value will be less. What should happen to pKb? It should increase.
Ammonia and amine.
I asked about ammonia and amines, right? And already we know amines are having less Lewis base character compared to amines. So in that case, ammonia should have the less Kb value, right? Ammonia should have the less Kb value. So therefore, when I am talking about ammonia, its pKb value will be high compared to the amines. All of you have understood? Still having any doubts or confusion is there? Right? So I can tell, to avoid the confusion, you can write this one also. So I can tell that pKb decreases from ammonia to amines. pKb value decreases from ammonia to amines. Right? But what will happen to the Kb value? Kb value increases from ammonia to amines. That's what we can tell. pKb value is going to decrease from ammonia to amines. But at the same time, Kb value is going to increase from ammonia to amines. Right? Whether it's clear? Any doubts? Amit, NH3 is less means what? Less basic. That means less Lewis base character. Okay? So now I have another question. We have discussed only about the aliphatic amines. We have not considered the aryl amines, that is aniline. If I consider aniline as the example, now I have aniline. That is an aryl amine. What will happen to the Lewis base character? What will happen to the Lewis base character? If I talk about benzenamine, that is aniline. Naturally, it should have very less Lewis base character. It will be having less Lewis base character, or I can tell high pKb value. Or I can tell low Kb value compared to other amines. Aryl amines will have the high pKb value or low Kb value. Even ammonia will dominate over aniline when it comes to Lewis base character. Now what is the reason? That is due to the resonance effect, positive resonance. That is due to the positive resonance. Due to the presence of positive resonance, as we have discussed, we have the aniline, we have discussed it for phenol, and even we have discussed it for chlorobenzene, right? All of them, they will show the positive resonance. So that's where electron will be shifted here. Due to that, electron will be moved like this. Now next stage where we will be having electron density over here. This will remain same. Double bond NH2. It will become positive. Right? So now next, since electron is present here, it will be shifting that one to next, and it will be moved to next carbon. Now comes the NH2 plus, then we have the double bond. Now electron density will be more here. Now next, this will be moving to here, and this will move here. So NH2 plus, then electron density is more here, and finally, so it will go back and it will go back to nitrogen. So finally we will be having NH2 with alternated double bonds. Right? So that's what we can see. Double bond has been changed. So that's where we have the positive resonance effect. That's where we have the positive resonance. Right? Now I have lone pair of electron. It will shifted towards the ring. So due to this carbon is taking electron, so this carbon will shift this electron to this carbon. So negative density is more, electron density is more. So then it will be circulated throughout the ring structure due to the presence of alternate double bond. So I can see that same as that of chlorobenzene, same as that of phenols, even aniline, it will have the positive resonance. That means it will have the electron density more at ortho and para position. Ortho, para and ortho. So they will be having more electron density at ortho and para position. Therefore, please remember, if I take a electrophile, if it is going for electrophilic substitution, next you will be discussing that one. So if you go with electrophilic substitution, then aniline will be ortho and para directing. That means electrophiles will attack either ortho and para position. They will not go to the meta position. So therefore they are ortho and para directing. Which one? Aniline. If I take nucleophile, reverse. They will become meta directing. They will become meta directing because at meta position comparatively electron density is not there. So therefore if I take a nucleophile, then it will be meta direct. Fine, but they will easily undergo for electrophilic compared to nucleophilic. Remember that. Same as that of phenols and same as that of the chlorobenzene, which we have already discussed. All of you have understood? And due to the positive resonance, aniline will be having very less Lewis base character. Very less Lewis base character compared to aliphatic amines. Compared to aliphatic amines, they will be having very less Lewis base character. All of you have understood? Any doubts? Okay? So in that case, if that is the scenario, I will be having substituted aniline. I will take the substituted aniline. It's not going, huh? I will take substituted aniline. So that is, aniline is more stable than anilinium. Yes, of course, because less resonance features shown by the anilinium. Okay? So I will come to that. So when I am talking about substituted, right? So NH2, this is aniline. Then I have the NH2 with methyl group, right? Then I have the NH2 with carboxyl. That means it is benzoic acid derivative. Now no more aniline. It is a benzoic acid because carboxyl, big boss is there. IPACE nomenclature always should give preference to carboxylic acid. So it is a benzoic acid derivative. So I can tell that para-amino or 4-amino benzoic acid. Benzoic acid. This is a common name, or I can tell 4-amino benzoic acid. This is one. Now this is aniline. IUPACE also, common name also it can be aniline or benzenamide. Now here it can be called as toluene derivative or amino derivative. If I consider it as toluene derivative, then 4-amino toluene. Otherwise, if I consider it as aniline derivative, I can call it as 4-methyl benzenamide. Anything is fine, benzenamide or aniline. So that's where I have the three molecules. Now can you tell me, among these three, which one will be having highest Lewis base character? Which one will be having highest Lewis base character among these three? Which will be having highest Lewis base character? Among this, which will be having highest Lewis base character? No one is answering. Naturally, I can tell that highest Lewis base character will be here. Then comes the aniline. Then comes the last one is this one. Someone had written para-amino benzoic acid. No, Kritik. No. So Manvit is right. Highest Lewis base character will be with this one because even methyl group will have the positive resonance. So amino group will also have positive, methyl group is also positive. Due to that, what will happen? Positive resonance of effect of amines will get slightly reduced. Now they can donate the electron bit easily, right? But here, due to the positive resonance, they can donate, but it will be bit slow. But when it comes to here, now carboxylic acid will have the negative resonance. It has electron withdrawing effect. Carboxylic acid or sulfonic acid or nitro group, all of them, they have the electron withdrawing. They will be pulling the electron towards themselves. So due to that, what will happen? Positive resonance effect of amine will be much more increased. Electron will not be donated easily because it is pulled towards the carboxylic acid due to the electron withdrawing or negative resonance effect shown by the carboxylic acid. So you have to remember that as there is an increase in the electron withdrawing substituent, aniline will become much more less Lewis base character. Aniline will show very less Lewis base character. As there is an increase in electron donating group or molecules showing the positive resonance, then it will be increasing Lewis base character of aniline. All this concept you should be thorough because it may be helpful for your competitive exams. Whether I am clear? So that's where I can say the arrangement. First, in your exam, if they ask, first you should see the nature of that substituent, whether it will have the positive resonance or whether it will have the negative resonance. So based on that, you can give the answer. All of you will agree? That's what I can see. Depending on the type of substituent, Lewis base character of aniline is going to be decided. As there is a substituent which is showing negative resonance, then it will have the less Lewis base character. As there is an increase in the substituent which is having positive resonance, then it will have the more Lewis base character. All of you have understood? But as a aniline, if I take, naturally it will be having very less Lewis base character compared to amines. So aryl amines will have the less Lewis base character compared to amines. Fine? All of you can do what, okay, next question is not that one, that is example, okay, fine. But all of you have understood? Any doubts? Okay, Amit was telling anilinium, yes. For example, we have aniline and in water, see, we will imagine in the water it has taken and it has become positive plus OH minus. So that's where we have the aniline and that's where we have the anilinium. Okay. Now if I compare these two, aniline, yes, it is getting stabilized by resonance. Aniline is getting stabilized by resonance. But when I am talking about anilinium, there is nothing to donate the electron to the benzene ring, right? So therefore, they are less stable due to the less resonance effect. They will be less stable. So these are the 2 points we should mention. Why aniline is having least Lewis base character? First one, due to the positive resonance. First point. Why aniline is less Lewis base compared to other amines. Second one is due to less stability of the product. Less stable product. Which is that one? That one is anilinium. That is anilinium ion. Okay? So due to these 2 points, aniline will be having least Lewis base character among the amines. All of you have understood? Any doubts? Any doubts? Yeah. Okay. So in that case, shall we move to the chemical properties? If you have understood, we'll move to the reaction. We are in chemical properties only. We'll move to the next concept. Okay. So these 2 points you can write due to the low Lewis base character of aniline. One is due to the positive resonance and second one is due to the less stability of the anilinium ion, which is the product due to the reaction. Fine? All of you have understood? So shall we move to the next concept? Next one is actually alkylation. Alkylation already we have discussed. Where amines can be easily alkylated by using alkyl halides. Amines can be easily alkylated. If you remember ammonolysis, in that reaction we have seen how alkylation will happen. For example, I have RNH2. If I treat with the alkyl halide, I am talking about alkylation reaction, which we have already discussed. Now what will happen? One H, one X here. So HX is going to get released. Now the product will be R. So this is nothing but alkylation. So amines can be alkylated by using alkyl halides. That's why we have the reaction, which we have discussed during ammonolysis process. During ammonolysis reaction, we have this.
How is the amine? Oh,
Okay, na? So this is what we have discussed in the ammonolysis. That's where we have the alkylation of amines. Fine. So we will move to the next one. That is acylation. Alkylation is different. Acylation is different. Right? So alkylation means addition of alkyl group. Addition of alkyl group. Acylation means addition of acyl group. This is nothing but acyl group. Adding this one. That is nothing but acylation. Fine. So now if I take primary amines. This is a primary amine. Now it can be easily acylated by using acetyl chloride. It can be acylated by using acetyl chloride. That is CH3COCl. That is nothing but acetyl chloride. Same reagent we have used during Friedel-Crafts reaction. Oh, someone has written. Very good. So that's what we have discussed in the Friedel-Crafts reaction. But this is not a Friedel-Crafts reaction. Fine. So we are not using FeCl3. Lewis acid we are not using. Primary amine with acetyl chloride. Right? Now, since there is a carbonyl group, oxygen will be torturing the carbon. It will be making the drama. Oxygen will be playing the drama. It will take the electron, it will give back the electron. It will take the electron, it will give back the electron. So what I mean to tell you is, this carbon will be slightly electrophilic in nature. So therefore, lone pair of electron is going to attack this particular carbon. Fine. Now that's where we have an intermediate H, CO minus, CH3 and Cl. Right? So this is an intermediate. This is an intermediate molecule. You can put square bracket or you can simply write it as intermediate molecule. Now, as I told, this oxygen will be acting as a mat. It will take the electron, it will give back. Now it is telling, no, I have extra electron. We can make the bond. It will tell to carbon. Now carbon will be under confusion. So what to do? So for that reason, since this nitrogen is also positively charged, so this bond can be easily cleared and this bond can be easily cleared. Because chlorine, electronegative, right? So now there will be formation of R and H, C double bond O, CH3. So what is getting formed? There is a formation of amide. Acylation will lead to the formation of respective amide. Right? So that's where we have the formation of the amide. All of you will agree? So we can call it as N-alkyl acetanamide. We can call it as N-alkyl acetanamide. N-alkyl acetanamide we can call it. Because acetic acid, what is acetic acid? CH3COOH. So acetanamide, that is because of this particular substitute. Fine. Now what should be the another product? Another product is HCl. Cl minus H plus HCl. So therefore, since there is a liberation of HCl, it has to be neutralized to make these reactions to happen fast. So therefore they will be using pyridine. This reaction will be carried out in the presence of the pyridine, which will act as a base. What is the role of pyridine? It will neutralize whatever HCl is getting formed, so that this reaction can happen fast. So that is the role of pyridine in this particular reaction. All of you have understood? That's where we have the reaction. Fine. So what is the end result of acylation? It will lead to the formation of amines. It will lead to the formation of amines. Same way, when secondary amines can show the reaction, But tertiary amine will not show this reaction easily. Tertiary amines will not show this reaction easily, or will not undergo this reaction easily, or it will not show. What is the reason? This can be one of the tests. We have many other. This can be one of the tests where we can use to discriminate between tertiary amine and rest of the amines. Right?
Means no effect on that. It won't release H plus.
That is because Mayank has given the answer due to the lack of hydrogen. Due to the lack of hydrogen in tertiary amine, it cannot easily go with acylation reaction. It cannot easily go with acylation reaction. That is important point. Fine. But primary and secondary, they can show the acylation reaction. Now this is one method for the acylation. Now I will change the reagent. Instead of acetyl chloride, I will use acetic anhydride. What can be the product? I will change the reagent. Instead of acetyl chloride, I will use acetic anhydride. That can also be used for acylation. Or NH2 plus CH3 CO O CO CH3. So naturally, even it can be done in the presence of pyridine. Even it can be done in the presence of pyridine, or if you don't have pyridine also, no problem. But pyridine, if it is that, fine. But I am telling option. Pyridine can be there or it may not be there. Then what is the reason? That is because instead of HCl here, we are going to have the acetic acid, a weak acid. Right? So one product is constant. That is alkyl, N-alkyl acetonamide. That will be constant because this bond will be broken. Right? So that's where it will go and it will attack to this carbon. And another molecule will be CH3COOH. That is acetic acid. Right? That is nothing but acetic acid. Okay? All of you have understood? Acetanilide, that is different. That is when I am taking aniline. That is different. Here I have taken a primary amine. That is not an aryl amine, alkyl amine. Okay? Okay. If I have taken aniline, I will keep this one as same. I will keep this one as same. But I will take aniline. Even aryl amine can show this reaction, no doubt. Right? Now what will happen? Now it will give rise to benzene, NH, CO, CH3 plus acetic acid. Okay? So now this molecule can be called as 2 carbon is there, acetic acid or ethanoic acid. 2 carbon, acetic acid or ethanoic acid. Based on that you can tell. You can call it as N-phenyl ethanamide. N-phenyl ethanamide. Acetylenamide, fine, or ethanamide. Better word is ethanamide. N-phenyl ethanamide. So nitrogen, since benzene ring is there, it's not called as benzene, it will be called as phenyl. Okay?
It should be methanamide also.
Methanamide means where CH3CO NH2. This is acetamide. Methanamide, if I want to write HCO NH2. This is methanamide. Okay? So formaldehyde and all it is there now. This is formamide. This can be formamide or methanamide. Anything is fine. Okay? So this is acetonamide. All of you have understood? So that's where we have the N-phenyl ethanamide, which can also be called as acetanilide. Which can also be called as acetanilide. That is combination of acetanamide plus aniline. Acetanilide. Okay, acetanamide plus aniline combination. Acetanilide. All of you have understood? So this is where we have the reaction. But when it comes to acylation, tertiary amines will not show the acylation. Rest all the amines can show the reaction. Fine? Anyway, this one we are going to discuss once again during electrophilic substitution reaction. Okay? But any doubts in this? So in that case, I will stop the class. Tomorrow we are going to continue. But any doubts in today's class? So with respect to Lewis base character, aniline we have discussed, where with respect to substitution, Lewis base character is going to vary. So that is bit important. Then we have discussed about acylation. Okay now? Okay then. Thank you. Thank you very much. Take care. Okay.